All right, so we're going to take a look at a few more problems just to help hit on some other ideas that possibly you could see and maybe open up your mind to help you with some of these things. As we go through, just I want you to pause and try it on your own, and then then watch and see what the way I go about it. So we're going to start off here with number 7. So go ahead, pause, try, and then I'll take care. All right, so this is our function, and it's kind of messy, but they love doing these sort of things. But g of x is f of x times tangent of x plus k of x, kx, not k of x, kx, where k is a real number. F is differentiable for all x, and f of pi over 4 equals 4, f prime of pi over 4 equals negative 2. For what values of x, if any, on the interval 0 to 2 pi, will the derivative of g fail to exist, and justify your answer? Okay, so, well, since we have tangent, all right, tangent's the key. Tangent has asymptotes. Those asymptotes are going to occur at pi over 2 and 3 pi over 2. And so for those values, then we know that there's no possible way to find the derivative at those values. And so that's where the derivative does not exist. So at pi over 2 and 3 pi over 2. So it doesn't even matter what f of x is or k is. It doesn't make any difference because tangent is undefined at pi over 2 and 3 pi over 2. So and that's the reason why those are the spots. All right. Now B says g prime of pi over 4 equals 6. Find the value of k. All right. So we have g of x equals f of x times tangent of x plus kx. So we're told what g prime of pi over 4 is. We're told what f and f prime are too there. So let's take the derivative. So we're going to take the derivative. And don't forget, with this part, you have to use the product rule. And then the derivative of kx, it's just like if it's the derivative of 3x, is just the constant, whatever that constant is. We're told that g prime of pi over 4, so we're going to use f of pi over 4, secant squared of pi over 4, f prime of pi over 4, and tangent of pi over 4. But k no longer has the x, so we don't worry about that there. Okay, g prime of pi over 4 is 6. F of pi over 4 is 4. Secant of pi over 4 is radical 2. So if we square that, we get 2. Plus f prime of pi over 4 is negative 2. And tangent of pi over 4 is 1. And then we can solve that little equation. Now, remember secant is the reciprocal of cosine. Cosine of pi over 4 is radical 2 over 2. So you flip that over, you get 2 divided by radical 2. A number divided by its square root equals the square root. That's how I know secant of pi over 4 is radical 2. That, and I've memorized it. So it'd be a good idea for you to memorize those things. So 6 equals 8 minus 2 plus k. So if 6 equals 6 plus k must be 0. So there we go. All right. Let's take a look at 8. All right. Pause it. Try it. The table provided below shows the position of particle S at several times t. Not really at any good broken up interval, just kind of spread out wherever. As the particle moves along a straight line, where t is measured in seconds and s is measured in meters. Which of the following best describes the velocity of the particle at t equals 3? So, 3 is between 2.7 and 3.2. And that's right there. And so we're going to use those two. We're going to find the average rate of change. And next chapter, we'll talk about what's called the mean value theorem that says that no matter what, if the average rate of change at some point will equal the instantaneous rate of change. So S prime of 3 is approximately 10.6 minus 7.8 y2 minus y1 over x2 minus x1. And 10.6 minus 7.8 gives us 2.8. And divided by 0.5, which comes out to be 5.6. And that's going to be meters per second, which must have been C. I choose C. All right. Try number 9. All right, I know the non-calculator portion had some implicit differentiation, but don't assume that doesn't mean that we won't have more tomorrow. But gotta write this clearly, otherwise I'll screw up again. Plus x squared equals 4. I gotta find dy over dx. So 3 times 2 is 6 y squared, because 3 minus 1 is 2 y prime, minus 3x y prime plus 3y plus 2x equals 0. So we take the derivative with respect to x on both sides. Power rule with implicit differentiation. Of course, you could write dy over dx if you like. Minus, we're subtracting, it's subtracting the entirety of 3xy. So when we take the derivative of 3xy, we have to subtract that entire derivative. And that we'd have to use a product rule with implicit differentiation. So the derivative of the last plus the derivative of the first. So the derivative of 3x is 3 and y. And then just 2x, power rule. We're going to get distributing that negative, so 6y squared y prime minus 3xy prime plus minus 3y plus 2x equals 0. I'm going to move these to the other side. So we end up with 3y minus 2x. Over here, we're going to factor out that y prime. And so we have 6y squared minus 3x. And so dy over dx equals 3y minus 2x over 6y squared minus 3x. Can't divide anything to simplify down, and that's okay. And now we're looking here, and you're like, wait a minute, I don't see that one. Where did Brant screw up this time? Didn't. B here is the same thing, just in reverse order. So if we were to multiply by -1 over -1, or factor out a -1 and divide it, or however you want to look at it, you can actually flip-flop those around, so that way it matches up, and we get 2x minus 3y equals 3x minus 6y squared. And you might be wondering, well, why would they do that? Well, some people are so biased in favor of x that they will make sure that they do whatever they can to make it be the first term. And, whether it's numerator or denominator, they'll do whatever they can. So, all right. Here's a related rates problem. Let's try it out. Okay. So we got the volume of a cylinder. Well, they gave us the volume formula. The radius and the height of the cylinder are increasing at constant rates. So it's, I don't know, you don't normally see that, but you can. So the radius is doing one thing and the height is doing another thing, which you usually don't see that, both dr over dt and dh over dt, but cool. At what rate in cubic centimeters per second is the volume of the cylinder increasing when its height is 9 centimeters and its radius is 4 centimeters? Okay. So we got this. So a cylinder. We got this cylinder. It's a can. All right. So we have R. And we have H. We know V equals pi R squared H. We want to find how fast the volume is changing. So how fast volume, that means dV over dt. That's what we need. So we're going to take the derivative of this with respect to time. So we end up with dV over dt. Okay. Now this one's going to be a bit of a mess, but that's okay. But it's just product rule. Pi is just a number, so we're going to treat that like it's coefficient because that's what it is. So our first times the derivative of the last, which will be dh over dt, plus the derivative of the first, 2 pi r dr over dt, times the last. And there we go. And we're told that r is 4, h is 9, dr over dt was 1/3, dh over dt is 1/2. So we're going to take all these things, we're going to substitute those in. We're going to get pi. If you want to factor pi out of everything, that might be helpful. R squared, so that's 4 squared dh over dt times 1/2 plus 2 times r times dr over dt times h. And we get pi, that's going to be 8. 16 times 1/2 is 8. 8 times 3, that'll be 3. 8 times 3 is 24. And so we end up with 32 pi. And then this will be measured in, well, if we have centimeters per second, they actually told us in cubic centimeters per second, but volume is cubic. Okay, so volume is cubic. That's what you want to be able to do. All right, if you noticed anything that was not on that non-calculator portion of the test that we did in this chapter, then you're going to want to expect that to be on tomorrow's. So things like linear, tangent line approximation. We didn't do that, so you can expect that tomorrow. Related rates. We didn't really do that, so you can expect that tomorrow. At least with these sort of things. If I remember correctly, I don't think a second derivative with implicit differentiation was there, so expect that tomorrow. But here's something for you, okay? Real important. So make sure you can use the derivative feature on your graphing calculator. All right. So I'll see if I see who shows up today, who shows up tomorrow, 8 o'clock. We'll go over everything we can before We have a full hour on Friday, so but whatever we can do to get you guys some help. So take advantage of it, and we'll see you soon.